Hello Junior Techies, my name is Natasha Barton, and in this video we will be solving problems involving bond polarity. In other words, we will make use of the differences in electronegativities between two atoms in order to establish what type of bonds exist between atoms. We will solve three different problems in this video. The first problem says, for each of the following bonds, use delta notation to indicate which atom is more electronegative. Then use an arrow to point from the less electronegative atom to the more electronegative atom. In order to solve this problem and all of the problems in this video, we're going to need a periodic table. Although I am displaying one to your screen at the moment, I will not do so throughout the video. So Junior Techies, be sure to get a periodic table and place it next to you so that you can solve all of the problems in this video with me. Taking a look at the periodic table displayed to your screen, you will notice that the electronegativity of each atom is indicated on the left-hand side of each element symbol. Question A involves the bond between hydrogen and sulfur. Looking at the periodic table, you will see that hydrogen has an electronegativity of 2,1, while sulfur has an electronegativity of 2,5. Now, since 2,5 is bigger than 2,1, we know that sulfur is exerting a stronger force of attraction on the bond pair of electrons between it and hydrogen than the force of attraction that hydrogen is exerting on this bond pair of electrons. So these electrons are being pulled closer towards sulfur, and as a result, hydrogen is slightly positive while sulfur is slightly negative. We can indicate this dipole moment, or in other words, indicate this uneven distribution of electrons between the two atoms by using an arrow which points to the more electronegative atom, which in this case is sulfur. Question B involves the bond between phosphorus and chlorine. Phosphorus has an electronegativity of 2,1, while chlorine has an electronegativity of 3. Since 3 is bigger than 2,1, chlorine is more electronegative, and as a result, phosphorus is slightly positive, while we indicate on the chlorine this delta negative symbol because it becomes slightly negative. Since chlorine has the higher electronegativity, the arrow points towards chlorine, indicating a dipole moment. Question C involves the bond between nitrogen and carbon. Nitrogen has an electronegativity of 3, while carbon has an electronegativity of 2,5. Since 3 is bigger than 2,5, nitrogen is slightly negative. It pulls that bond pair of electrons towards itself, while carbon is slightly positive. And since nitrogen has the higher electronegativity, the arrow points towards nitrogen. Taking a look at all of the answers, you will notice an arrow between each pair of atoms. This shows us that the bonds between all of these atoms are polar bonds. Ladies and gentlemen, having done this, we have completed the first problem in this video and can move on to the next problem. This problem says, use a calculation to determine the type of bond that exists between atoms in each of the following. In order to solve this problem, we're going to make use of the table displayed to your screen. You can find a copy of this table in your theory booklet that you can download from the Junior Techie website. This table shows us how the difference in electronegativity determines the type of bond that exists between different atoms. Types of bonds that you need to be familiar with include non-polar covalent bonds, also known as pure covalent bonds, weak polar covalent bonds, strong polar covalent bonds, ionic bonds, And some of you may also be familiar with metallic bonding, but we will not be dealing with metallic bonds in this video. Question A involves the bond between hydrogen and iodine. To calculate the difference in electronegativity, we always take the larger electronegativity and subtract from it the smaller electronegativity. In this case, iodine has the higher electronegativity of 2,5, while the electronegativity of hydrogen is 2,1. So we say 2,5 minus 2,1 and obtain an answer of 0,4. Now, since 0,4 lies between 0 and 1, we know that the type of bond that exists between hydrogen and iodine is a weak polar covalent bond. Question B involves the bond between hydrogen and fluorine. Fluorine is the most electronegative atom on the periodic table. It has an electronegativity of 4, and we subtract from it the electronegativity of hydrogen, which is 2,1. This gives us an electronegativity difference of 1,9. 1,9 lies between 1 and 2,1. This tells us that the type of bond that exists between hydrogen and fluorine is a strong polar covalent bond. In question C, we are dealing with the bond between magnesium and oxygen. Again, we calculate the difference in electronegativity by taking the electronegativity of oxygen, which is 3,5, and subtracting the electronegativity of magnesium, which is 1,2. This gives us an answer of 2,3. 2,3 is bigger than 2,1. So here we are not dealing with a covalent bond at all. Instead, we are dealing with an ionic bond. In this case, magnesium will donate its electrons to oxygen, so that magnesium forms the magnesium 2 plus ion, and oxygen forms the oxygen 2 minus ion. These ions will attract to form the magnesium oxide ionic crystal lattice. In question D, we are dealing with the bond between carbon and sulfur. We calculate the electronegativity difference, but while we do so, we notice that both carbon and sulfur have electronegativities of 2,5. 2,5 minus 2,5 gives us an answer of 0. So here we are dealing with a non-polar covalent bond, also known as a pure covalent bond. And notice that this is the case even though the atoms are different. In order to have a non-polar covalent bond, we simply need the electronegativities of the atoms that are bonded together to be exactly the same. This means that there is an even sharing of electrons between carbon and sulfur. Having done question D, we've completed this question and can move on to the last question in this video. The last problem in this video says, the following diagrams represent the bonding that takes place in a molecule. On the left-hand side, we have a Lewis diagram, and on the right-hand side, we have what is called a Cooper structure. While in a Lewis diagram, we indicate electrons and bonds by making use of dots and crosses, in a Cooper structure, a bond is indicated by a straight line. So notice that between carbon and each hydrogen atom, we have a single bond, while between carbon and this mysterious element X, we have a double bond indicated by two straight lines. The rest of the question says the electronegativity difference between element X and carbon is 1. Identify element X by means of a calculation. Now, since they've made mention of the electronegativity difference, we know that we will probably be making a electronegativity difference calculation. Before I do any calculation, let's familiarize ourselves with the clues, the hints, the puzzle pieces that we have available to us. taking a look at the Cooper structure or even the Lewis diagram, you will notice that between carbon and element X, we have a double bond. This tells us that element X, which is only bonded to carbon, is only able to make 2 bonds. I'd like to remind you that it is the group 6 elements that are able to make 2 bonds, and only 2 bonds, because they have a valency of 2. So we have some idea that element X is probably a group 6 element. We can list the other information available to us, namely our electronegativity difference is 1, 0, and since carbon is bonded to element X, we know or write down that the electronegativity of carbon is 2, 5. Remember, we are only interested in the bond between carbon and element X, so we don't really care about the hydrogen atoms on the sides of the carbon atoms. They're not bonded to element X at all. Now we need to calculate or use the electronegativity difference calculation in order to get closer to finding out what element X is. So we say the electronegativity difference is equal to the electronegativity of element X minus the electronegativity of carbon. Now you might wonder why I said the electronegativity of element X first and then subtracted the electronegativity of carbon from it. Remember that when we calculate the electronegativity difference, we always take the larger electronegativity and subtract the smaller electronegativity. Now, how do I know that element X should have the larger electronegativity? Well, remember when we were dealing with the octet rule and the different ways of drawing Lewis diagrams, we said that the central atom is the atom with the lower electronegativity. So that means element X probably has a higher electronegativity than carbon. And that is why I said the electronegativity of element X and subtracted from it the electronegativity of carbon. Manipulating this equation, we see that the electronegativity of element X is equal to the sum of the electronegativity difference and the electronegativity of carbon. So we say 1 plus 2, 5 and obtain an answer of 3, 5. Now I'd like each of you to go to group 6 and try to identify which atom has an electronegativity of 3, 5. You should find that the atom with an electronegativity of 3, 5 is the oxygen atom. And this means that element X, which we needed to identify, is the oxygen atom. Ladies and gentlemen, this brings us to the end of this video. I'd like to remind you that all of this information that you've just learned is very important, especially when it comes to determining the type of molecule that you have, so whether a molecule is either polar or non-polar, which is important to determine what type of intermolecular forces exist between compounds. Do your best to understand this content, and remember that the best way to get everything into your head and to keep it there is to practice. So be sure to download the worksheet from the Junior Turkey website and to practice as much as possible. Thank you so much for joining me. I hope to see you in the next video.